Hi, welcome to my first video. As it was explained on the work plan, we are gonna use the system to go through the second unit. The second unit is about relief. Now, as you already know, we're gonna skip some parts because there are certain points on each unit that you already learn about them, you already review them in the subject of biology and geology. So basically we're gonna skip those points. We need to go through the same parts over and over, and we are gonna go to the new content. As I just said, this unit is gonna be about relief and relief formation. Before going into the several types of reliefs and specifying each concept and learning what relief is, we are gonna start learning about a really interesting phenomenon called the tectonic plates. This theory states that the Earth crust, the lithosphere, now you remember what the lithosphere is, I'm sure, it's a really thin layer of the Earth, just on top of the mantle. The lithosphere is the layer where we build and walk, basically. So it's the superficial layer. As I said, is really thin, but however, is very important. So this theory states that the lithosphere is divided into several smaller parts. Those parts or blocks are called plates. Those plates are smaller parts of the lithosphere, as the North American plate. Even though they are smaller parts, they could be pretty large, like the North American plate, as you can see here, or the Eurasian plate, shown in green, continues here until the east side of Asia. Other plates are smaller, like the Caribbean plate over here, the Nazca plate, and the Philippine plate. Think about the Earth as a 3D puzzle, and those small pieces of the puzzle are the tectonic plates. Observe that every tectonic plate included not just the emerged areas, like for example Asia, but the submerged areas on the Atlantic Ocean. More than that, observe how the limit between the North American plate and the Eurasian plate is divided just in the middle of the Atlantic Ocean. Iceland even is an island between two different plates, as you can observe here. Those plates are not static. In other words, they are constantly moving around in a real reduced place. Now, at this specific moment, they are moving even though you can even notice it. But as I said, the pace is extremely limited, extremely reduced, just a few centimeters every year if you're lucky. Why is moving? Because they are on top of the mantle. Mantle is it consists on a series of semi-solid materials. They are not quite liquid, but it's like the tectonic plates are like floating into the mantle. Just try to imagine like several pieces of cork floating in water, moving just on a limited and reduced pace. Just a couple of questions for you to try to make you understand this process better. Are the plates similar to the continents? Well, if you pay attention to my explanation, no, they are not the same as continents. And this is the first differentiation I want you to make. Plate could include an emerged area, like for example a continent and part of the ocean, or they could be just oceans with a few islands, like the Pacific plate, or they could include a huge amount of emerged areas like the Arabian plate and a few submerged ones, but they are not the same as continents. Can we find plates with no emerged areas? Sure. Well, sure, more or less. For example, the Pacific plate, as it was shown here only a few islands, including Hawaii, for example, but the majority of the territory is completely submerged underwater. Well, as I said, those plates move, and those plates, as it is shown here in this picture, they are limiting one to each other. Some plates limit with several other plates. North American plate with the Euro-Asian plate, with the Caribbean plate, with the South American plate, with the Pacific plate, you name it. So, as they are one to each other, close to it, they tend to collide, to separate, or to slide past each other. It depends. You'll understand this process with this picture. So, just follow the lines. Some plates, they collide. So you can find one plate on one side, one plate of another, and they are moving one to each other. As they are moving one to each other, they start colliding. We're gonna see what happens when they collide, don't worry. The second movement you shall remember is when they separate. When they separate, the process is different. Those plates are moving on the opposite directions, as the first example shows. When this happens, the semi-solid materials from the mantle located here, they go up. We're gonna learn about it in this class later on. Finally, they could slide past. When they slide past is the second example. Those plates, they are moving on a parallel direction. The impact on the relief is limited. So, example. Let's say that, for example, the African plate and the Eurasian plate are colliding. It meant that this plate is pushing north until it collides with this plate. The consequences are huge, even though nobody is gonna notice those plates colliding, at least not at first sight. It could have some side effects that we're gonna learn later. So let's start with the first movement. Oh, by the way, this collision, separation, and sliding, they are responsible, among other geographical phenomena, of the Earth relief. In other words, the mountain change, for example, the Rocky Mountains, they are a consequence of those tectonic plates colliding to each other. You're gonna see examples. So, as I was saying, collision. One plate pushes to another. In this case, when there's a collision, the thinner plate goes down the mantle because it's lighter and it melts. Now, pay attention to this picture. So we got two plates colliding. Plate number A on the right side and plate number B on the left side. This plate is thicker, it's heavier, which means that when plate number B on the left side starts colliding to plate number A, as it's thinner, he goes down. And these other plates, let's say that gets mounted on top of the thinner plate. This is called a process, or the process of subduction. But don't worry about it for now. This is an overall situation of what happens when they collide. You can see it better. Let's say that this plate is colliding with this second plate. As it's thinner, the ocean plates are always thinner than those plates that got emerged areas. This plate goes down, as it is shown here. When this plate penetrates into the mantle, they melt. So in the inner layers of the Earth, the pressure and heat is huge. So this small layer, they will start melting and being part of the semi-solid combination of materials in the mantle. The force of the collision tends to cause the formation of mountain chains and other geographical phenomena as volcanoes. So, for example, this mountain chain shown here, it will be caused by the collision of both plates. The force of them colliding will cause this. It is not random that this volcanic activity shown in one of those red triangles, it is located just in the boundaries between plates, as it is shown here. So for example, the collision between the Pacific plate and the North American plate will cause the formation of the Rocky Mountains, as well as volcanic activity. Let's learn about the other two movements. The second one is the separation movement. It happens when a plate moves in an opposite direction, so they are not colliding, but they are separating one to each other. In this case, the materials from the mantle, they're going to push up into the surface, and obviously they will become colder and they will solidify. So this is the situation. Plate number A is moving on the opposite direction as plate number B. As it happens, the semi-solid materials from the mantle, they are gonna go up, and then they will start being solid as they get colder on the surface. This is a real example of what happens when there's a separation of plates. This is a picture of the Rift Valley, one of the most significant places on the Earth where the separation of tectonic plates caused these chasms shown in this picture. Finally, the last type of movement is to slide past. As I said, one plate moves on a parallel direction to each other. Again, example number B. As I said, sorry about that. Yep. As I said, the impact on the relief is reduced, is limited, even though the slide past movement can cause other geographical phenomena as earthquakes. Good. Let's go on how this movement of tectonic plates affects the relief. So, as I said, colliding, separating, it modifies the relief. It's on a really long term, as they are moving just brief centimeters every year. You're not gonna notice how the relief changes, but in 1,000 years, in 10,000 years, a million years, the relief is gonna change. Depending on the materials, the force of those tectonic plates colliding and separating can cause two different types of relief: the fold relief and the fault relief. Now, the fold relief, it is created when the internal forces they are acting into flexible and soft rocks. When this happens, they create a curvy landscape like this one. It would be example number 1, a curvy relief. You have to think that one force is pushing from the left, another from the right, and the result is this curvy terrain. This is a real example of how it looks like. Now, the second example is the faulted relief. It happens when the force modifies rigid and hard materials. So instead of following a curvy pattern, instead of this, the relief tends to break, to say so, to create a fault. This is how this kind of relief looks like. Second example, the faulted relief. Observe how the relief is completely broken here because it has no room to just follow a curvy pattern. It is not a soft material, so it breaks. A real example, well, casual example, to think about how it works is to apply force to two materials that you can find in your own home. If you apply force to a rubber, for example, to erase pencil, you could observe how the rubber is gonna fold, alright, because it's a soft, flexible material. On the other hand, if you apply this same force into a pencil, the pencil is a hard, rigid material. So the pencil, if you apply, he will fold a bit, but if you apply enough force, the pencil is gonna finally break. So it's the same happening with the relief. Finally, as I said, just pay attention of the volcanic activity just on the areas where two tectonic plates are one to each other. This is caused by colliding or separating. Also, those areas are earthquakes, for example, are really typical in those areas due to the movement of the tectonic plates. Alright, so we are done with the first point. Activities, page 31, activities 4, 5, and 6. I want you to follow the same delivery system as you did previously. So send it to my email, even though it's explained on the work plan uploaded in the web page of the high school. Well, I hope you enjoyed. I hope you learned just a bit about relief formation. See you in the next video.